Okay, welcome back to Learning Programming in Python. I'm Mirkov, and today, the first lesson, we will talk about basic operations and variables. Let's start with some motivation. When we're writing a computer program, we're essentially writing a list of instructions that a computer could follow. When you're talking about these sorts of recipes, sometimes you'll hear two different words used: an algorithm or a program. The key difference is that an algorithm is a set of instructions to solve a problem. This can be any sort of problem. A program is a set of instructions a computer can follow and is an implementation of an algorithm. I'd like to remind everyone now that all information in a computer is represented by bits, or sets of bits which are called bytes. So in our computer program, we'll have several variables which represent data that we want to manipulate in different ways. However, since all data on the computer is represented by bits and bytes, then how can we tell one piece of data from another, or what it means? The trick is that inside of our Python program, whenever we have a variable, it's keeping track of what those bits mean by using types of variables. The four most common types that you'll come across in any programming language are integers, floating points, strings, and booleans. Integers are the counting numbers and negative numbers that you're used to. Floating points are often called floats, and they're any number that has a decimal point in it. Strings are a list of letters that are used for printing messages onto the screen and things along that nature. And booleans, which are sometimes called bools, which are variables that only have two values, either true or false. In Python, we don't have to manually declare what the type of a variable is. In other languages, you would. Instead, Python figures out what type of variable it is based on the type of information you give it. Here we have a sample program where we set the variable x to 1, y to 2, and then we print the value of x. X prints out the number 1. Then we set x equal to y plus x, which makes x now equal to 3. We change the value of y to 10,000, and then we print out x. Notice that the value printed out is 3, not 10,003 or anything like that. This is because each instruction is executed in order, and the y represents the number 2 when the x equals y plus x is run. So that says x equals 2 plus 1. This might be different than most variables you're used to working with in mathematics, because instead of a variable being able to change its value based on some inputs, you set the value and then it doesn't change until you change it again. I use the variable names x and y to represent the two variables, but there's no special reason why these should be what you use. There are restrictions on what you can name variables. They must start with a letter. They're case sensitive, so capitals do matter. They can contain letters, numbers, or underscores. And in general, they should be meaningful. So anytime you have a variable, you should name it something that if a stranger were to try to read your code, they would kind of understand what you were trying to do. For example, if you had a program and you had a variable called var3, it's not really clear what that means or what that variable represents. But a variable called high score has a good name. You can read that and instantly know this variable must represent some high score in a video game or something like that. No matter what name you pick, the name has to be unique, so there can be no other variables or functions that have that same name. For example, you can't name a variable print because print is a special keyword that you use to print messages to the screen. So we know how to declare a variable and assign it a value. What sort of things can we do with this variable? Well, let's say we have two variables that are both integers. We have x and y. The first thing we can do is we can negate a variable. We can add two together, we can subtract, we can multiply, and we can divide, of course. Notice that when we take x and we divide by y, 5 doesn't go into 3 any times, so the result is actually 0. Similarly, if we take 5 divided by 3, we get 1, because 3 goes into 5 one time. This might be a little confusing, but just remember, since we're working with integers right now, the result of the operation will be an integer. To help deal with this, there is an additional operator that you might not be used to, which is represented by a percent sign. This percent sign means modulus, or modulo. When you take x mod y, you will notice that the result is 3. This is because when you take 3 divided by 5, you get 0, so y goes into x 0 times, and the modulus then takes the remainder of that operation, which is 3. So there's 3 left over after you divide x by y. If we take y mod x, we get 5 divided by 3, take the remainder. So the remainder in that case would be 2. So if you want to make an operation and then store it in a variable, the simplest operator is simply the equals operator. However, there are a variety of other operators that you can use. To give you a feel for that, if you had x plus equals y, that means x plus y, and then take that result and make x equal to the result. Once we start having more complex equations, the order of what we're doing starts to matter. So if we take y and we add that to x, and then we change y, this doesn't change the value of x. In the third column here, we can see that we have a little bit more complicated equation. We have 1 plus x times 2 plus 1. And what you'll notice is that the order of operations is being followed, where multiplication is done before addition. In the fourth column, we can see that we've added a set of parentheses. Based on your knowledge of mathematics, you know that parentheses will happen before multiplication. So we'll do everything inside the parentheses, thus giving us 1 plus 3, which is 4, times 2 is 8, plus 1 is 9. So adding parentheses can help make it more clear or change the behavior of an equation. In the final column, we show that you can actually use multiple assignment operations within the same line. This is considered bad style most of the time. What happens here might be a little confusing, but essentially you read this from right to left. So it says set y equal to x, then set x equal to y. Since this isn't the easiest thing to read, especially if the equation was more complicated, this is frowned upon. Generally, you would not change more than one variable on the same line. In this case, it would be much better to have 2 lines of code where it says y equals x, and then on the next line you said x equals y. Next, let's take a look at floating point numbers. Whenever you want to represent a floating point, you just make sure that your assignment has a decimal point in it. Notice that y is still an integer. Any operation between either 2 floats or a float and an integer will create a floating point result. So addition, subtraction, multiplication behave essentially the same. However, notice that division, now we actually will get the proper floating point answer instead of the rounded integer answer. Finally, for your homework, write a program that takes a Fahrenheit temperature and converts it into Celsius, and then outputs those values. Try a couple different temperatures of Fahrenheit to make sure the conversion is working. If you're not sure how to convert the temperatures, then look it up.